Yeah, okay. Welcome everyone. It's nice to meet an audience, even though it's a day after a public holiday, which is also a Friday. I'm glad to be here. I've been here for 2 months almost already. So coming from the University of Helsinki, I'm going to spend 1 more month. And I think it's a good moment for me to now present what I've been doing this far. So I'm a PhD student in consumer economics. I was here presenting last year, and I'm going to use, I have an empirical material, a Finnish online discussion forum as my material that was given to me, so I'm very empirical and very hands-on in a sense. The material consists of discussions of 15 years of online Finns, and there's, I think, roughly 55 million comments that can be mined. But this discussion today is not about that material. I wrote one article about it, and the next article is going to be more literature oriented, and then the one after that is again going to be an empirical one. The main topic, my main interest is this, which is a pulse. So with people in consumer economics, but also in different other fields of social sciences, there's always some kind of a ripple, and then there's things going on, and then people are infuriated, or they get happy, or they're interested in a brand and they buy lots of the brand, and then somehow the popularity wanes. And this waning, this interest going down is the specific point, but I'm most interested in the actual mechanism. What is kind of driving this thing? And you could say that it's a linear thing, like two-dimensional, but of course in social sciences, especially say sociology, you can look at things as a network that is spreading this kind of phenomena if they are suitably, if the networks are built in a suitable way. So network analysis. I'm trying to steer clear from the network analysis, but we'll see if that is possible. And also the network analogy goes nicely with the online idea, of course, but because online and Internet of Things is a huge network on top of the world. Today I'm going to be discussing 3 things. So the first one is like my original small idea of audiences waning. The second one is about the article that I'm writing here, or that I'm studying for here. And then the third one is like my thoughts on how things could be. So, or what could be happening. And if we had any discussion, then I'm sure that this is at least the point where other thoughts can come into my mind, and that is actually one of the reasons why I'm here and why I'm very happy to present, so that I might get some new ideas. So, so if you have a brand and if you have a product, I'd be working as a user researcher in product development in business. 3 most typical explanations for why people don't like your products anymore are these. People are satisfied with the thing, they don't want any more of it. So you know, everybody has an iPad, so why should they buy one? And so the sales are going down. It could also be that people just get fed up. So it's been enough of this type of ice cream, and now I want to change, right? A second reason that is often offered is that the brand has done something, or the company has done something to betray people's feelings or their likings, and this could be a press issue, so that you know, a CEO behaved badly at Uber Uber, so people aren't leaving the service, for instance, both the employees and the users, for instance. But it could be also something more, something less clear. A third option that is often offered is that I think this is more long term, and this has more to do with like a cultural evolution, that the brand used to be very relevant at some point in history, but not anymore. It doesn't feel authentic anymore. You could say that a TV show from the 50s describing the relationship between families and the kind of humor that the TV show has doesn't ring a bell with us anymore. So this is why you constantly get different films or film interpretations. For instance, the Superman film or Batman film, they have to be redone every now and then, so you get a new face and a new technology and new music, hit music, and things like this. So these three, according to this article, but I think it's a good presentation, are most typically offered. But this study, which kind of showed me as the starting point from a consumer economics point of view, they also strove to find reasons that are a bit more internal, something else, something that the audience itself does. It's nothing that the brand did or didn't do, but something that the audience does. And they found out, studying a TV show, US TV show called US Top Model, that went through different installments. They actually found out that the brand started going downstream. The popularity started to go down after the audience itself and the greatest fans actually started doing something against the brand. So they kind of started undermining the popularity. And then they were studying how could this be and how did this unfold. And what was interesting to me was that it seemed internal, you know, like it was not an effect from the outside, but it could be something internal to the system that somehow things become unstable and start going well, badly for the brand owner. And then, of course, I started to think: is it because the audience is evolving somehow? So is there some kind of a drift among the audience that they started to like different things, or how did it go? But after visiting the lectures of Francis and reading the lecture notes and the discussions that we had, it actually occurred to me that it's probably so that the brand has evolved, because one of the theories that Marjoriikka and Fisher discussed was Deleuze's assemblage, so the assembly, that the brand, like a TV show, let's say Harry Potter, you have a Harry Potter brand, but it consists of several elements. So you have the actors, you have the films, you have the books, you have the writers, you have the fun merchandise, you have all the events, you have the news stories, and it's all those small little elements that make up the brand. And some of those elements start changing, and then another element starts changing, and they evolve, and then they might be pulling into different directions. And that could be the kind of a drift, or it could be even intentional, but that could be the kind of a phenomena that actually makes the audiences forget the brand. So and this occurred to me, so that even though the article and then the writers were focusing on the audience, so something happening with the audience, I was thinking that, yeah, well, actually, perhaps it was the brand. So the brand was evolving. But the outcome is that the theory and the idea that I thought that I had, that this could be the one that I use, I don't feel very comfortable with it anymore. So it could be something different that I need to find. But there is one thought that I have left about this assemblage, and then a drift. That if I were able to find an assemblage of people, or study an assemblage of people, and then a drift, or for instance the powers that are taking them slightly apart but somehow it sticks together, so then perhaps that group could be studied and their evolution could be studied. So it's an idea. But this came to me only after I was here already. This was unplanned. Now, what I planned to do here, and what I was supposed to do the minute I arrived to Belgium, was to be writing code. Because one issue that I have as a consumer economics student is that there's different disciplines involved. So consumer economics is like, it's really highly multi-economics field, which is unusual. I can't deny that consumer economics is a subfield of economics. Yes, it is. And economics is usually very, very insular. They stick to themselves. But this is, according to my professor Heinonen, all these fields have to do with, have an element in consumer economics, and you can come and be a consumer, study consumption if you come from these fields. So in Finland, in Northern Europe, in Nordic countries, you have the social policy part. There's legislation that concerns consumers and consumption. Food sciences, home economics. Home economics is very much the home of consumer economics in Finland, and then education, and I can tell you that I have PhD student friends who come from these fields, and my focus, my past lies with the science and technology studies, because I'm an engineer, I'm a media engineer, and I've studied communication, so that is also there nicely. I've studied history, social and economic history of modern times. I've done some marketing stuff and studied that with product development, and then I recognize that all of this has to do with economics and sociology, and my supervisor is an economist, and my colleagues are sociologists. And what I'm saying here is that I have enormous amount of theories that could be matched with machine learning, and I think that exactly because there's so many possible theories that might share even some elements between each other. They just might be different in their focus. The task seems very difficult, but I'm sure that I will be able to do this. In the course of my studies, I've already recognized that these two fields, social sciences and then the method way of computer sciences, are very different in their approaches. And I'm glad that I found an article by a sociologist, Professor DiMaggio, who's actually listing them. So you have two very different disciplines that need to be reconciled, and with the method and the material and the theory. So one difference is that the social scientists, if they are quantitative, they prefer statistical explanations. So they learn one method, could be interviews, could be surveys, and then they try adapting it everywhere and use statistics to check whether it works, right? If they are qualitative, they do the interviews. Obviously, they don't care about statistics, but the quantitative sociologists, for instance, are interested. But with the computer scientists, it is different. They don't bother calculating p-values. If your current algorithm isn't working, you write a new one, and your model works if it seems plausible. So if you're fine with it, and if it's better than the previous one. So it's very pragmatic. If it works better than the previous one, then you're good. I recognize the computer scientist in myself in this. Other thing is that social scientists, because they study people and humans, they don't trust humans. They don't trust human interpretation because they know that biology is social pressure, context, weather, whatever, can affect your judgment, and you can measure it even in your brain. Whereas computer scientists, because they write code, they don't trust code. They know that the algorithms are always man-made. They can fail in the hardware, and they can fail even in ways that they don't realize. That you might have a piece of code that has worked beautifully over 5 years, and then suddenly it crashes, and you never know why. I think I trust code less than people. At least in my case. Yeah, so I'm more suspicious of code because I know how it can be. It can be very bad. A third point that DiMaggio makes, I'm not quite sure about this one, but I have no reason to disagree, is that he says that social scientists tend to prefer unsupervised machine learning, which means that they just give the data and then they get something out, because this is something that gives room to interpretation. And that allows you to interpret. But on the other hand, the difficulty then is that how can you define quality? How can you say that the outcome is good? Because you don't have the statistics necessarily. Social scientists tend to be suspicious of supervised machine learning, where you, for instance, might give a list of words that these are the important words. And they are suspicious because they know that the list is incomplete, it's my interpretation, things like this. So I can recognize this in my colleagues, but the other end then is that the computer scientists are often making predictions. Yes, I suppose so, especially in business. So they are building models much like economists. And how that happens is that you take a little sample, and then you train your algorithm, and you test the quality of your algorithm with the notion whether your algorithm was able to predict what will happen with the data that you know that actually happened. But I have a little issue with this because I've studied history, and I know that there are limits with using history as a predictor for future. So I'm not very comfortable with this part of computer scientist, alleged computer scientist credo. Now the third problem, I already mentioned that the issue, so I'm a consumer economist, and I had a dozen of disciplines I could be vaguely familiar with. But especially in high growth fields like engineering and computer science, there is an increasing amount of papers coming up. What to do? I can't read them all. So there are a couple of solutions, especially in the field of medicine. There is a tendency to do literature reviews. I've seen many computer science articles that are basically just listing the past research that has been done and then kind of grouping those findings together. Successful careers are made of this type of reviews. And then especially for the medical students or medical researchers, there is machine learning tools available. So you can you can scrape automatically the abstracts, or you can do some kind of a pre-screening, or you can just handle the text in a database, or you name it. And I'm mentioning here a Python package that I started to use because I'm going through Scopus. I'll be discussing that shortly. But how it usually works is that the packages are available in the internet. As you know, there's somebody who wrote a blog, and this is how it's used. And this specific package has been originally written by a Carnegie Mellon professor, Carnegie Mellon is the biggest and largest machine learning unit in the US, a top US university, and then it has been enhanced or edited by a Cape Town economics PhD student, and I think I'm going to be posting my code online once I'm comfortable with that. So what I came here for, or what I wrote basically in my application for funding, not in this much detail, but the idea was that I will write a code that will fetch abstracts from Scopus, and I'm using Scopus because it appears to be the largest academic database for social sciences and computer sciences, so I don't need to write different APIs. And like I said, there are existing packages available, and it's nice to have the API there because, for instance, I have friends who are working on their PhDs 5-7 years ago, and they told me that when they were trying to do something similar, they got banned from the service. But now the publishers are more ready for this kind of activity. Okay, but then I get the abstracts. I have a pile of them. Then I need to write a code that finds or categorizes the topic somehow.
How do you select the abstracts?
In next slide, I will show you the keywords. So the next, once I got the abstracts, I need to digest them somehow. And this code I already had basically written because I did a topic modeling, LDA. I think I mentioned that the last time around. And my purpose was to find what are the current research problems in the field of online, as you will soon see, and what are the methods, perhaps finding some theories that are used to be able to do the matching. And analyze, discuss, write an article. Very easy, but not really. And I can tell you that in this case, because the abstracts are from so many different fields, it's taking a long time to go through them and read them to really understand what's going on. Typically, writing the code takes most of your time if you're writing it for the first time. But if writing the code took me 2 to 3 weeks, I'm sure that reading the articles or the abstracts is going to take double that. So and then I will write an article about the whole thing somehow, and then I will find a suitable method for me to write an empirical article. So that is kind of the longer term point. So I can use my material to its fullest extent. So next I'm going to show you the Scopus search terms. There's 5 groups and then a couple of limitations. I will first discuss the limitations. So the 2 rows at the bottom. Language only English, publication year only after 2015. So last year and this year. And this is because Scopus only gives me 5,000 abstracts at one time. So I can't try to get the whole history because it's 60,000 abstracts. So the easiest way to limit the amount that the search gives you is to tweak the publication year. And also there's the subject areas. I can return to that soon, but if we go through the words, and I know that they are not very good, so this is the first phase. But the first group is about online, because that is where my material originates from. I want to know about online material that's being used or people activity online instead of ethnographic studies in rural Russia, for instance. So, yeah, not all terms are directed to online purely. For instance, there's just plain text. But this is because I noticed that in abstracts, you might be, for instance, you might be actually doing you might have done a simulation and never mentioned the word simulation in your abstract. So you never knew it was a simulation. You could guess by reading it, but then you have to go read the actual text. So not every significant term is mentioned in the abstract, sadly. The second group is machine learning. So that is the wide family of methods I'm using. Transactional data, for instance, is something that you get when people are paying and using online banks. So there's a transaction. So I was interested in that kind of data being used. Support vector machine is a method, web mining, trace data, sentiment analysis. These appear to me to be very current terms. The third group is, because I'm studying consumers, we have household, we have customers, of course the consumers, actors, but also not just people themselves, but also their behaviors and acts and attitudes. So you get the discourse and frame and human whatever tastes. Taste is very much used in consumer economics. A human taste, like food, how you taste food, but also your taste in fashion. Fourth group is then about the movement. So that is also discussed very differently in different disciplines. You have time series, evolution, there could be a transformation, there's a dynamic, something is contagious, self-organization, bursty behavior, cultural change, all levels. Because I want to remind you, my material spans 15 years, so there's actually, it's a very long time. There are some cultural changes online. There have been cultural changes online behavior during the last 15 years. And then the fifth point, so research and analysis and study, that's actually necessary to include to be sure that I'm getting empirical research, so not theoretical considerations, but research that is actually testing a theory, because this was my goal to get an understanding. Could be that there are some interesting theories going on, but if I left this one out, I would really have to tweak the publication year or something else, because then I would get all the theoretical considerations, and that would again explode the results. So with this listing, and then the subject areas. So I got business, computer sciences, decision sciences, economics, physics, psychology, social sciences, and then multidisciplinary. So this combination gave me a little under 5,000 articles. And I think that I already spotted, Cadell, your article was there. I didn't take names, but you were there. I don't know which spots you hit, but something there caught my eye. Yeah. So then I got pile of articles, or pile, it's actually a very small Excel file, but many lines. And then I did the programming, and here's what I found. And in a sense this is very interesting, but in a sense it's also not very interesting. But so the LDA method gives you as many topics as you wanted to find. And I started with 10. And I'm going to show you a table next. So there's 10 columns. Each column is a topic, and I'm supposed to give a label to a topic. And every topic is spanned or described by keywords, and there's 10 of them. So there's 10 times 10 table. And this is actually the format how these outcomes are usually published in articles too. But the 10 topics is purely my invention. It's basically coming out of a number of disciplines that I have plus a few, right? So if all the disciplines were very different from each other, I would probably get one for business, one for computer sciences, one for economics, and so on. So it's like an educated guess, the 10. But usually how it goes, you start with, say you start with 10, then you do 200, then you do 5. You know, you have to vary it a bit. But the interpretation depends on actually reading the abstracts then. So you are, as a researcher, you're the one giving the label and saying that this is a sensible combination. So there they are.
Very common.
Yeah.
Words.
Okay, I'll make this easier for you. If we start from the left, is a topic with words application, cloud computing, internet, device. So this is very engineering, right? So then you get the next one. It's also engineering in my books because they are talking about images of videos, and when I go through it, it's about online videos having quality difficulties while they should be faster. So YouTube problems could be faster to see things if we did this technical change. This type of a thing very often. A third engineering topic has to do with wireless sensor networks, which is currently a huge thing. It has to do with, for instance, self-driving cars and cloud computing, kind of high analysis heavy things, when, especially in an Internet of Things network, when people devices are becoming more intelligent, but you can't afford. There's too much delay if they all of them try to access the same Google headquarters to get their turn to do some calculations. So yeah, so these are very timely, very pragmatic considerations the engineers have. I could detect a business, an economics related topic there, so you have management and markets and business. Then this I named, or this I consider to be a physics oriented topic because they are talking about particles and material. And there was another topic that also spanned or used words that have to do with, among other things, that have to do with physics, so compression, deformation, stress. The thing is that actually, and this is very typical, the same topics gets mixed with social words, social sciences words, so a child and a family, and you could say that these are very different, but you could say that also there might be some conflicts and for instance, a child may be having conflicts or symptoms in the family, and then there is a model that tries to explain them, and then they try to find if the intervention has any effect, so that you might have a program that tries to help children in low-income families to not suffer from these symptoms. And apparently there's something in the language used that is common with these physics terms. But the most likely thing that I will do, or what I will do, is I'm going to try to get more topics, and it's likely that these two will then split. And if they don't, then it's also an interesting finding. There was another term that has to do with people and their roles. So student, I'll get back to that soon. So the issue with this engineering addition, so you get also language and software here, and you could say that students learn, but then also software learns a language, so it's about machine learning languages. So the term is actually, the hinging term is learning. So this is also a topic that needs to be split, most likely. This topic is potentially a bit more pure social scientist topic, because you have social and online media there. Or this is how it appeared originally. And then we have the health topic, and health studies often have behaviors, and health behaviors are discussed, and then there are interventions, and they are trying to see their effects. And then there was one topic that I wasn't, I really didn't, I couldn't say any discipline based on this. I think that feature is something that appears with languages. So languages have features, software has features. What else? So this is going to split also. Now I do have a slide where I discuss the theories and the interesting things that I found, but I'm not going to show that because this is a work in progress and it's going online, but we can discuss perhaps after the session. So the next slide that I'm going to show is an alternative interpretation of the results. Okay, so here I gave the names. This is the introing title for these 10 topics. So the 3 engineering topics: health topic, business topic, physics topic, social topic, and then the one that was comfortably split between social and physics. One word that obviously caught my eye, because I'm an engineer with a background as a user researcher and product development, is the word user. Okay, so engineers have the word user. You have a technology, and the technology has a user, so that is no surprise. And it's in there in the weird topic, but it's actually also mentioned in the social topic, so it's likely that the social topic also has some elements that are a bit more technical. Could be like the fields that I have been working with, so social and technology studies. We also have a term node, which goes with the network, wireless sensor networks, and node is in that case, it's typically your phone is a node. So technically the node is a device, but in the current days the device is usually used by a person. So I'm carrying my mobile, and the mobile is moving because I am carrying it. So the developers need to be aware of people's movement. And also, if you are developing self-driving cars, the cars might be empty from time to time, but very often there's possibly a person inside them, and a person who calls the car and wants to ride a Uber or wants to ride the future driverless car. There is a human making the call. So node technically is a device, but there is a person behind it, or several people, right? Yeah, so we already discussed that there were a couple of different roles. for humans in the social sciences topic, and then with the learning topic, the weird one. With business, it's the markets and decisions, so I've been better able to grasp like this kind of a macro level economics as well as the decision-making sciences instead of actual consumer sciences, because consumer science is a smaller area within economics. And then we have the word behavior, which as a target for health studies is a person behaving healthily or unhealthily, but with physics it's actually the particle that is behaving, and that I think is a nice finding, and that actually explains why I took physics in, because to me it appeared that the particles moving could somehow be at least a metaphor for these kind of groups evolving that I mentioned earlier. Truth to be told, it could be possible that the physics approach is a bit too heavy for me. I can't necessarily find any metaphors that I understand well enough to explain them in a social way, but yeah, it's still there. And funnily enough, you notice that the last engineering topic doesn't discuss people at all, so it's very heavily technically oriented, and I can definitely recognize that kind of a discourse too. So the users are not there. It's only about the algorithms and performance of technology. Okay, so at this point I think it's a good thing to say that I already mentioned, I whined a bit, that in the abstracts they don't necessarily mention how they did the thing, the researchers. So it appears that very often, however, at least in this group of abstracts, they do mention the human or the focus of their interests. And another thing that they typically mention is what they achieved. So what goal and what outcome they had. And with this engineering problem, with engineering topic that has no interest in people, they still have a problem and then they are proposing a solution. So my video system is not working, but this algorithm might help. And here's my proposed solution. And the other engineering topic is using the same approach. With social and physics, this could actually be the link between the social and the physics topic. So there is some kind of activity or a program that gets done, and it's either it has an effect or it doesn't, or if it's published research, then there probably was an effect. But the effect of A to B, so there was an act and then there was an effect, is in focus. Effect is also discussed with the health topic, because they have the interventions, so people are behaving not well, and then there is an intervention, and they hope there is a better intervention.
How do you separate those columns? How did you separate those topics for those columns?
That is the outcome of the analysis.
It automatically puts it into separate lists of 10 topics? Or?
Yes, because I told it that I want 10 topics, so then it gives me clusters that are closest to each other if I only want 10. And then if I wanted 15...
But the topic means a collection of keywords.
Topic means, yes, in a sense, yeah. So the topic is like a discourse. So these words appear often together, so they define a topic.
Okay, so the columns are words that tend to appear together.
Yes.
Okay.
Yeah, more often than they characterize it better. Yes. So the word effect is probably used elsewhere too, but it's just more often mentioned in these two. Yeah, it's actually there with the physics topic too. Influence. So if you compare it with the topic, with the word affect, so in a social context, you could say that there's a tendency to be less firm with the causality. So you're not saying that A caused B, but you're saying that A might have influenced B. So humans are influenced by certain things, instead of saying that too much traffic in the network will crash the network. So, conclusions. This is not something that I'm going to write in an article. It's just what have I found? I found the popular themes, which especially in the case of these engineering and hard sciences, so particles and cloud computing. I found the outcomes of research, a little bit of the used approach, but that was not as present everywhere. Then with the second reading, I could find some, get an idea of what the focus of research was. And mind you, this is something that I wanted to consider after I realized with the first article that actually the evolution is probably happening with the brand instead of the audience. So this is something that I will try to concentrate on more. And then the roles of humans, of course, they came through the keywords that I had selected partly. And yes, then I found a couple of interesting research methods. I want to mention one. There's this one called ABC, which is artificial bee colony. So it's about how bees move in colonies and are somehow coordinated and able to, or fish can move in colonies and they can do some things somehow in a coordinated way.
It's called the swarm.
Yeah, but the method or the algorithm that is currently used is called artificial bee colony, ABC. And there is also, I'm not sure if it's only one version or a proposed version or if it's different vein, is called cognitive artificial bee colony. And I don't want to talk about them much because I don't know much about them. I need to familiarize myself with them at some point. But what I'm trying to say is that this idea of an assembly of people who somehow evolve and do things together could be perhaps be matched with methods that are developed and currently in use, which is always nice. So because this is pretty much everything that I have been able to do this far. So I'm continuing with my reading. I need to read the analysis to split the topics, and it really is a needle in a haystack when it comes to methods, because a new and interesting method is only mentioned a couple of times, and it's not present everywhere. Like a survey is, every third social sciences paper is doing a survey of 2,000 people. But the new methods, you really need to comb through the material. But at this point, then I would move to the third part, which is about finding a match between a method, a material, and the theory. And who can find it? Because I'm using machine learning, I'm not an artificial intelligence researcher, but of course it's there because people in the field are also interested in developing artificial intelligence, and it's in the news. And one of my professors is interested in developing an artificial intelligence. I will just give you a few thoughts. So about overlapping terms, and this is about cognition too, and the concepts that we have and how brains think, but this is just the listing. And this is only a short listing when the professor was already interested. So you have a feature, like I said, the word feature is used and it means a different thing in language technology and computer software, but you might see how they are related. So it's a sub-part of something larger that defines the large part. Then you have a frame. This is actually the first one that I realized. So in language technology or language studies, a frame is something, and also in sociology, but the focus is a bit different. A frame is something that people discuss about. So it's a talking point. But in engineering, a frame is a small architectural construct within which data is transferred in the internet. So TCP, API, and then you have a certain types of frames, and they are certain size, and it's very specific. Whereas the language technology and especially the sociologist frame are not. And then this was surprising then to me. So media, I thought, yeah, media. But communication is considering media slightly differently to engineering, because engineers think media is as a technology. So you have a TV technology, but they don't think about the TV business and the TV journalists. And then with physics, of course, it's like, yeah, you've got soil. And then soil is a media, and it could be, you can put electricity through it, or you can't, things like this. So it's, yeah, surprising. And I'm sure that there are many others, but these are the three that I have found this far. The cognition and concepts, and how do we map between different disciplines and between different languages, and is science decomposable? And as I already mentioned, and as you might have noticed, I think the hard sciences, so the engineering and physics, were easiest to spot. In a sense, economics is the hardest of social sciences. So they were easiest to spot because they use very distinct terms to a very distinct phenomena. So it's apparently easy to find with an algorithm, because you concentrate on those words. But in social science it's a bit muddier, and then I was thinking that, okay, this could probably be mitigated so that you first try to find the hard sciences, and then you conclude that if this term here, for instance, effect, doesn't have the hard science meaning here, then it's probably the social science meaning, you know? And I would guess that the Iris AI, which I mentioned also in the abstract, could be trying to take this kind of a route. So Iris AI is, it's a startup. There's a couple of people who have been, a few of them have been through Singularity University, and then the reason I'm, aware of them is that because I'm a Finn, and one of the founders is a Finn, and Finland is a small country, and I know people who know her and hear about this thing. So so basically what they have already said is that hard sciences is easier, and they are trying to, so they are basically trying to create an artificial intelligence that would allow scientists to put their research plan into their service, and then they propose you articles that can help you with your research problem. And this is for free for scientists, but the same service will be charged if companies want to use it. And I think it's very ambitious, but like said, they are already themselves, they are admitting that it's working somewhat with natural sciences, but social sciences are hard. And my colleagues are trying, I think they plan to try it out.
What are the...
I don't know, I haven't been through, but could be some kind of deep learning. At least they will claim it is about deep learning because that is fashionable. Yeah, but it's I would guess it can be a combination, and then it kind of starts to teach itself. But yeah, I think it's an interesting exercise. You know, them coming from the Singularity University, you could say that they probably want to develop a scientist. So first it starts to understand what kind of topics, what kind of articles to look for, then it starts to propose research problem itself, and then it starts to making experiments itself. I don't know. But yeah, it's interesting. I don't know about their funding situation or how long their funds will last. But yeah. Okay, so other considerations. So I think I did two different, and this actually relates also to the iris. So I think I did two different kinds of interpretations on the keyword. The other one was literal, so I have the cloud computing, I have the health, but then the other one was a bit more semantic, so I was like interpreting the roles of people in the abstracts, and then I was interpreting the purpose of the researchers from the words. And this brings me back to the DiMaggio point that social scientists and computer scientists view the interpretation differently, so that I might start with, I've noticed myself to start with the computer scientist version, which is the literal one. So this is talking about health. But then the next step is the social scientist interpretation. But I'm not sure how much the algorithms or the artificial intelligence is able to do this kind of a semantic interpretation. This only occurred to me now, that I'm not sure if there is a there has to be a combination of literal meanings with the semantic models that have been developed over the years. And if there are other levels, you know, and other types of modeling, and then those combined could make it this kind of a text analysis more viable with artificial intelligence, because I have been personally a bit skeptical this far, but when I realized that the semantic level can also be modeled in different languages, I was like, yeah, well, perhaps there are even more options there, and all those get combined into one intelligent system. And then, of course, the last caveat is then about the interpretation totally. So I already mentioned that the search words are not perfect, and all the social scientists are always wary of such lists, because they are affected by my researcher background. So I'm an engineer. I tend to use the user, all the engineering kind of words that I've been using because I've been working in technology companies. I'm quite sure that if my supervisor, who's an economist, had come up with a list, it would be very different. So that is, and you know, that is obvious. All those keywords are then devised by a group of people. But then I can also, on the other hand, I can kind of counteract this with, well, then if I just took everything, or if I took one seed article and started moving from there, which is a popular way of doing things, is it somehow more neutral, or is it more genuinely neutral? Because already it's been said that I see algorithmic analysis as an interpretation, and there are also humanities people who think that the outcome of an algorithm is an interpretation and that is actually fiction in the same way. There is just this tendency, a way of speech, to think that algorithms are, perfect and they never make mistakes, and the judgments that they make are more neutral than any judgment that could be made by a group of people. So
I think this is being debunked now quite thoroughly now.
yeah, I think I think it is,
Right.
and perhaps not in popular
Right.
media, but among scientists, obviously. Yeah.
Well, an algorithm has some inbuilt criteria for what it takes and what
Yes.
it doesn't take, and those inbuilt criteria were put there by a person
Yeah.
who, for whatever reason, thought that it was important, but it's subjective.
But the difficult part is, for instance, the one that we discussed when Martha was giving her presentation, that, for instance, if we have a social security system that is giving benefits to people based on an algorithm, it is not inherently it's not neutral, because there might be mistakes and there might be some kinds of preference orders that are just put in, and the outcome is not.
Yeah, but that's why the
Perfect.
algorithm needs to be scrutinized
Yeah.
by as many people as possible, so that the one can correct the biases, the prejudices of the other one. That is
Yeah,
why
this is-
algorithms ideally should all be open
Yeah.
access, open source. The problem is, if it's complex software, it's not sufficient if it's open source for you to also to understand what it's doing.
Yes, and in government systems they haven't been open, but I understand that Microsoft even put their code online now, and for instance in Finland they have put some code online in GitHub so that people can actually go through that. So I think it's improving, but I think it should improve in this way, like you mentioned, before we are moving into a system.
And the other thing is that you test algorithms by applying them to different types of data and then see what you expect that a good algorithm would get out. And if it systematically gets out different things than you expect, then you can try to see what are the biases of the algorithm.
Yeah, I think it could be, if I think the best thing would be that it's open and that there are people who are actually like tending the algorithm, because the other option is that, I don't think it can be left just to the citizens to consider, because then we might end up with something like Wikipedia, when you actually still have the 10-12 activists that are focusing and who take their time for a couple of years. So I think that type of for instance, government operation would still need to have resources, so we can't like outsource it to the citizens in hopes of saving.
I think the government should put a lot of resources in it, because on the one hand automation means that lots of things that before used to demand a lot of manpower and money now can be done automatically. But on the other hand, it also means that the way it is automated, that means that particular algorithms now will need to be tested and checked and scrutinized. And so it's just that the amount of effort that you put in may not diminish, but it will go to different things. Not at doing the trivial things, but at doing the difficult things of scrutinizing whether the algorithm is doing exactly what you want.
Yes, I agree. This is what I would hope to have, but yeah, it's more expensive than just getting rid of the people. But yeah, we don't have plans like this, I don't think, in Finland. Okay, so this about like the government replacing decision making with algorithms or whatever part of business. But then a question that we've been discussing, and I've been interested in this one. So if you say that the algorithms introduce results that are fiction, that are interpretations, like what humans
I
do.
think there's a difference between fiction and interpretation.
Okay, sorry. I quote this writer who studied fiction, and she said that they are fiction because she studied fiction.
With fiction you can really
Yeah.
invent anything. You can invent
Yeah.
aliens coming down on Earth and so on. Or with interpretation, it means you very selectively take out certain things and put them in a certain light.
Yeah.
Some parts of it may be fictional, but you're still starting from something real.
Yes. I think interpretation is the better term here. But anyway, so they are producing, let's say, interpretations. They are not perfect. They need to be curated. And we've been talking about creativity here, and there's talk about ethics and whether we should be afraid of artificial intelligence. So I've been thinking that what would it actually require that humans accept that interpretation as an intelligent outcome coming from an intelligent, let's say, the Irish AI social scientist or a computer scientist, because I think it was not the last time, but the one before that, we were discussing about consciousness also a lot. So how would we know that a computer has a conscious, or an artificial intelligence has a consciousness, or how can we be sure that it doesn't? I was very much intrigued with this thought further because I mentioned in my abstract that you probably know that Google Translate switched the algorithms behind the translator into a neural network, and after doing that, the results for Finns started to be very strange, and my Facebook was flooded with people testing this out. But basically what happened was that people put their name, Finnish name, into the Google Translator that I have used to translate some things from academic articles, and then they started getting very weird results. I'll show you this guy because Helsinki is a small city, and I know this guy. So I'm trying to show you this Google page. Desk. No? And then I'll show you the website with the news. No, where is it? Okay. So this was in BuzzFeed. So he writes his name, and this is the translation. and what actually happens there is that his name is his name is.
I think it's one of the tabs up there has a sound.
His name is a Finnish version of Saint Michael, Saint John, and then the surname is a certain type of land, like agricultural piece of land. So the translation is nowhere near. This guy's name is, this means a certain kind of a stone. This is a Saint Stephen, and this is an ancient word that probably couldn't be translated just like that. And here you have a lady whose name is I am Catherine Wilhelmina, and this is a Latin word. They make no sense, and everybody was just baffled. We were like, what is happening? And I can assure you, everybody was thinking that Google was pulling our leg as a nation. It's like, I didn't put my name in. The lady started to get nasty words out of it for some reason. So I probably might have recognized that this, these are guys' names and these are ladies' names. But the outcome was that the Google said that, okay, we are working on it. And at least I was thinking that, okay, perhaps Google didn't pull our leg, but what if the artificial intelligence did? So it was having a great fun. So I will leave this at that. In a more practical sense, I can assure you that this kind of events surely do kind of undermine our belief in artificial intelligence. I don't know if anything similar has happened with your languages, but like native non-English languages. But
I remember I got a stage translation, but I don't remember what it was.
Yeah, but with these, I finished the presentation, and it would be interesting to discuss. And there's the GitHub, but doesn't have this code yet. So thank you. Do you have any questions or comments on?
Well, I had the feeling that your selection of abstracts was very kind of broad, not very specific. And because of that, also the topics you got out of them were very broad and very non-specific, like words like problem, propose, user information. You will find in almost all abstracts something like that. So
yeah, but that
we propose the study to collect data about users of something. I mean, these are typically the kind of stop words that you find in abstracts. It doesn't really say what they have done. And these are the most common words, so your topic analysis will find these common words, which are the least informative in a sense.
Yeah, that is true. I think, like I said, the next step is to come up with a better, either to come up with a better list of keywords, to come to limit the subject areas. So I might be tempted to drop the physics and psychology, for instance, but then also kind of like to reconsider if I should. The other option is just to seriously to somehow drop something from here, or drop these very generic words and take some very specific words.
I think you have too many generic words.
Yeah.
Like mechanism, comparison, understands, predicts. You will find it in almost any scientific paper.
Yeah, I think that is the
research analysis. I mean, find me your last one. Find me one scientific paper that doesn't have any of these words in its abstract. Not analysis, not research, not comparison, not review, not mechanism, not insight, not understand, not predict, not forecast, not explanation, not simulation.
It is
actually all scientific papers will have one of these words in their abstract.
I started with 4 million, and each of these steps kind of slashed the previous one into half. So it's
but the
surprising.
question is whether you are selecting in an informative way. I mean,
I agree
the
with
more
you.
constraints you put on it, of course, the less you will have.
Yes.
But if you put constraints that are very generic, it may just be a chance that somebody called understand and another one said understood or grasped or.
Yes, I understand what you're saying, and that is this kind of a unless I am better able to defend the choices. This is exactly the situation that I'm going to have, and this is the type of discussion that is had every time there is a list of keywords. That do you have them all? And I can say that no, I don't, and I'm not happy with the list. So you just start with this, and then you try to make it smaller. I agree with you. You are right. It's not a good list. It's a starting point, and unless I'm able to make a better list, like for instance, just use one word, all the articles with the word temporal dynamic. It's it's a bit.
Yeah, but that's also dangerous. I mean, one technique that usually works better is using citations. If there are certain standard works in the field, you look at all the articles that cite that. that usually gives a better idea that they are in the same topic.
Yeah, I've
And the
considered
more they
that.
cite these articles, the better. I mean, if you
Yeah,
have a number of standard articles on machine learning or data analysis or whatever, and then you could just say that the more a paper, the more of these papers are cited by that paper, the more
Yeah.
likely it is about this.
Yeah, I see. I know what you're saying, and that has been proposed. The issue, and I'm probably going to try that next after going through the articles. But the thing is this, that for instance, economics is so insular. I have seen articles actually measuring how much they quote from other fields. They don't. And because I'm working in economics, consumer economics, I have to take both economics, and then I have to take all the others, and then I would, as a next step, if I did what you proposed, I need to do it separately for each of the fields,
Yeah.
and I was trying to condense the amount of disciplines at first, and yeah, I think the physics and psychology
ideally,
are
indeed,
topic.
you would not look at existing communities, because like that you tend to stay within existing communities, but look at multidisciplinary work where somebody in a different discipline may do something similar, but the problem then is that not only he may not cite the same papers, but he may goal his research differently. He may use different keywords.
Yes.
And by using very general keywords like you did, you will find lots of irrelevant stuff that is just general scientific research that has something to do with the internet, but almost everything nowadays has something to do with the internet.
Yeah. I think the correct heuristics is to try all these different ways, like the citation thing, and then checking.
What you can do is try to find a number of abstracts or papers that do fit your criteria manually, because you recognize them, and then see what are the most common keywords in those.
Yeah, I think that is probably going to be what I will do at the end, and that is how I will write my article. But I'm ready to admit that all of this is also a bit part of my PhD process, in the sense that I have been most consumer economists come from one field, so they are very strongly economists or sociologists, for instance. But I have been multidisciplinary from the beginning, so I kind of have to negotiate my way. What is in the focus of my personal interests, and this is part of that process. But in the end, I agree. I think it's easier to write an article where I say that this is the heuristics that I used, instead of saying that first I did this. First I had a keyword list that was bad, and then I did this. Then I did this linkage thing, or a reference thing, and then I diminished the number of disciplines, and I don't think I'm going to explain the whole process. But the outcome is eventually going to be a very different 5,000 abstracts, or actually it's probably going to be more like 100, I hope. So it's going to be more focused.
The problem you always have when you're trying to define a field that's not yet defined is that you will need to do some bootstrapping. That means that you use part of the results to find other results, and then vice versa. Once you have these new results, you can add them to your pool and then refine them to find more of the first types of results. So for example, you start with a number of papers that you think are in the field, you see what are the typical citations, what are the typical keywords, you use those to search for more, and then in your expanded version you may again extract keywords and again extract citations, and then do the exercise again a number of times, and each time your group of articles will change somewhat, but hopefully become more and more the pool of articles you really want.
Yeah.
So you will generally get more articles, but at a certain moment you may also see that you start losing articles, because with the new articles you get better keywords and better citations, which then exclude some of the old articles because they were kind of marginal.
Yeah. I recognize the process. I think it's the in technology studies, like I mentioned, they still tend to have this tendency that they list all the studies that have done something similar to theirs. So it's not like they are core, but they are just instead of theory, engineering sciences, or what engineers call theory, all the past experiments. So they list all the past experiments they have found in the part that is reserved to theory in other disciplines. And I'm not kidding you. It's literally done. So who writes the theory part, and then the theory is finding all the experiments that are done. But so if I was writing for engineering audience, for instance, if I was developing an algorithm, I would have to list much more articles, whereas in social sciences it would be exactly that. If you're talking about frame, you have to cite Goffman. If you're talking about complexity, it's good if you cite Herbert Simon, kind of thing. But so that is also a decision that I need to consider. I mean, that will become. I need to consider it when I decide who's the audience for this, because I haven't decided it yet. The option. I removed the slide.
So what was your general purpose? So you want to get a survey of the research on what specific topic?
Groups of people who are focusing their attention to one topic and then they don't. So there is a phenomenon like this.
So the brand, not the brand loyalty, but the brand disloyalty.
Yeah, so it's a mechanism that repeats itself, so that there is
where loyalty builds up
and then it goes down. Yeah, and it sometimes
but then
might
I think
come
your
up again.
keywords are really much too broad.
Yeah.
But on the other hand, it's true that it's not obvious unless that is a well-recognized phenomenon in the literature which keywords you do use. But at least some of the literature will know that under certain names, and these keywords you should certainly include. Like you spoke about the pulse and I don't know, there are a couple of others.
And overflow is mentioned. Overflow is the specific moment, and then it's like innovation diffusion in the case of decision sciences. I think the issue is rather with the how a theory that already exists could be studied with a method that is used to study a fairly similar phenomenon, right? So that, for instance, these findings about the I found the the methods that I find in the engineering field, in cloud computing and wireless sensor networks, but also some in physics. For instance, there was something called van der Waals force. It's something to do with molecules attracting.
Yeah, it's a weak
it's like
molecular attraction.
Yes. Yes, without being chemical. So that type of a thing could, for instance, be seen as a bond between people. You know, not necessarily only in the level of metaphor, but also providing a methodological.
It's good, but it's kind of unlikely that the social scientists would use a van der Waals force as a metaphor, because they first would have to know exactly what the van der Waals force is.
Exactly, but this is what I'm talking about. So that, for instance, with the child and family topic, and then the compression and deformation. I found there were talk about, there was several mentions about physics term anisotropic. Isotropic?
Anisotropic or isotropic, yeah?
Both, yes.
Yeah. Anisotropic means that it's not the same in all directions. Isotropic means it's the same in all directions.
Yes. So you could say that is, for instance, that could describe polarization in society, like political stances.
Mm-hmm.
Then I was actually reading a book by Why Nations Fail by Daron Acemoglu, which is an economic history book about, he's making a statement about how institutions are necessary for nations to survive, have to have like beneficial institutions. But he's also talking about this kind of a mechanism where every time, even if you have old rebels and then they become new elite, there is always a threat that the new elite becomes too stuck in its ways and too much trying to guard the abilities and power to extract power from the system. So and that is when the other rebels, the new rebels, come, and there might be a coup or they might be somehow engaged in the system that actually then becomes stronger. So you could say that, for instance, I got the idea that this kind of isotropism could be, you could consider it as the reason, or it's a metaphor for this kind of a stiffening that happens with the elites. And this idea could be rubbish, but with this term anisotropic, I actually found out that online police, there was an article where police or somebody was, they had developed an algorithm to find basically people who spread child porn in the internet. Child porn.
They searched it?
Yeah, they find these people, they locate these people because they behave differently to others. So they were developing a heuristics to find these people based on their behavior compared to other normal, nice people. And they were using this term. So what I'm saying is that from biology, but also then physics, they are lending this type of metaphors, or like, what would you like to call it, inspiration to do this kind of a model development of algorithms. And I find it very interesting, but I also find it has to be very specific, and you really have to understand, well, if it's only inspiration, then it's nice if it gives you an idea, but if you use it as a metaphor, then you really, like you said, you have to know what somebody has to know the physics. But I understand that there are lots of physicists in the field of complexity studies.
Yes, there are lately.
Yeah.
The physicists are kind of getting bored with their own domain, so they're
Yeah.
trying out in more interesting domains of social science and networks and finance.
Yeah, yeah. So the keywords are bad, and this is my personal process at the same time. Yes. Finding a method, and I would be confident to say that when it comes to cloud computing and wireless sensor networks, then that is the domain from which I can lend methods. because I've done that earlier. So not the physics one, but the engineering.
Yeah, it's not so obvious how that would apply to social processes. That looks really like kind of more hardware-like stuff.
But there is, like I said, you have the word node there. So
yeah,
and
node
then you
can
have
mean lots of things
yes.
lately. It can also just mean it can be a physical node. It can be a mathematical node in
yes.
a network.
Yes.
It can be a computational node.
Yes, but then so if I wanted to concentrate, for instance, on the methods and like the idea of wireless sensor networks. So this one was about the self-driving cars and such. So if I wanted to focus on that kind of thing, then I would obviously try to select the node that is about node in that sense. So together that the node that goes together with wireless sensor networks. Yeah, but it's tough exactly because you have to limit the discipline, but computer science and engineering both are so wide. There's so many new articles and Scopus doesn't allow you to, you would have, I think the next level is to go to either to the university level, when you could say that, okay, this university doesn't have this engineering department. You either go to university level or you go to the journal level. So it's really high level discipline that they are allowing you to search. I think, yeah, it should be made more refined, but that's how it is. Because if I could just pick subfield, like subfields under computer science, that I don't want the artificial intelligence, but I do want the language technology, it would be much easier. Yeah, so it's also about the tools. You have to negotiate with the tools that are available. Yeah, so it's more likely that I get more crap in the outset, that in the beginning, that I get more crap than I get valuable stuff, and then it's like, what's the word, you try to find gold like this.
Oh, sifting.
Yeah, sifting, yeah.
You're an archaeologist?
No, we do that in Finland. We don't have real gold mines. People do this for fun. They actually enjoy it. It's a hobby.
Do they sometimes find something?
Yeah, I think my friend gave his wife a ring that was made of gold that he had found through his life,
Over how many years?
Yeah, over how many years? Yeah, exactly. 20 years. Yeah. I think the refinement of the search is definitely the thing to do.
Yeah, I think you need to do
but I also have to go reading the articles, because that is, or the abstracts, because that is kind of supporting finding the right keywords or the approach. And for instance, the guy I mentioned, the University of Cape Town, Southern African guy, I think he was doing this kind of a reference-based search. So the packages also have that element kind of there. I just need to update it, so it's I don't need to start it from scratch. And yeah, it's been recommended. And then starting from seed articles that I find interesting is definitely a thing to do. Yes. This is taking much longer than I thought. I thought it. I didn't think it would be fast, but I thought it might have been faster. That's, yeah. I've noticed this throughout the PhD process already too. Yes.
By the way, connecting this with your previous seminar, I suggested at a certain moment that an interesting paradigm is a paradigm of alignment.
Mm-hmm.
I've read a little bit more about it, but it's not really. They're doing different kind of experiments. They're not using text material. They're looking at people who are communicating, and then they often force them to invent new symbols or new ways of expressing things, and then they see that after a while they align on certain terms or on certain symbols, and that these symbols after a while tend to become simpler, and that everybody in the community understands them then. And that is, I think, what also happens in a new scientific field. You have different people independently that start looking at the problem, then they start meeting each other, and they don't use the same terms to speak about it, but they tend to align themselves. They tend to start using the same terms, and in the beginning they may use complicated terms like complex adaptive systems, and then afterwards they reduce it to complex systems or to CAS or something like that. And after a while it becomes kind of a standard term, and then you have the keywords for your discipline, and then you can find it. But that takes a while. That's not an easy process. So it would be interesting if you could document that process happening, but then you need a period of time, and with your other data about the discussion forum, you might be able to find it.
We have discussed about this, and I find it very interesting. And that actually also, I think, relates to the isotropic idea, because in the book by Acemoglu, reading that, so the idea of stiffening, you could also say that the discipline gets stiff. Don't quote me on this, but economics is getting a bit stiff. Because
economics is stiff already for a very long time.
The stiffening is also visible in the language, right? So what I was thinking in relation to this alignment is that once the alignment is kind of almost done, and everybody in the field knows that these are the terms, and every newcomer must learn exactly those terms and exactly the meanings that they are given, you're actually preceding the situation where you are almost too stiff for your own good. But if you are a bit more open to external influences, this is the one article that I mentioned that said that economics is hardly referencing to anything else with economics. That article, the writers of that article were actually saying that the disciplines that lend from others more freely seem to be more creative. So I think that one plugs in very nicely to the idea of that. First you have this kind of a creative chaos, and then you start aligning, and it's always elite that aligns the best. So you're aligning, but then you become a bit too stiff, and then it kind of crashes down. So that is like the way I understood the anisotropism thing, that if, for instance, a piece of wood is anisotropic, and it's very strong, wood is strong like this, because you're hitting it from the other direction, but if you hit it from here, it's very easy to crash. So you kind of, if you end up having a discipline or a ideology or a system, minority rebels, if they come and hit you like this, so then your system will crash. So that kind of a dynamic, so that is how the anisotropism could be related with the alignment. So first you have the alignment, and then there is a potential for crash if it goes too far. You see what I'm saying? Yeah. But I don't know if there is such a theory, I mean like a social scientific theory about this. The way I've seen it, very often recent theories about dialectics of some kind. So there's kind of two elements, the A and B, instead of like the internal thing, just described like the alignment. But then you have something that comes like this, but it's due to your own actions, kind of, that it comes.
Well, in a good complex adaptive system, you have both processes. You have the process of alignment of those that are already in the system, but then there is a constant input of new things from outside the system, to which the system then will have to adapt, which means that its alignment may have to change, and they may have to agree about new concepts, and they may have to abandon some of the old concepts. So it's this edge of chaos thing, like you should have a certain order, enough alignment to be able to coordinate well, but you should also be open to constantly new influence, because otherwise you freeze and then you become breakable, you become the opposite of almost fragile.
And then one more thing that I found about the anisotropism and isotropism on a cell level in biology, because they apparently there are like actual mechanical forces in action within a cell. So I think, I'm not sure if this goes the right way, but I think what they were saying is that if the power is anisotropic, inside the cell that is causing the cells to multiply. Okay, so you have the mechanism that cells multiply from time to time, but what is it going to be? What is going to be the outcome?
It needs to be anisotropic because they need to pull the chromosomes apart into two halves. They can't pull them in all directions. They have to pull them in one direction and not in the others.
But I think the claim was, but if the force is anisotropic, it might be the other way around. If it's anisotropic, then it multiplies, and then you get the same several times. But if it's isotropic, then you actually end up producing molecules that are supporting the life of existing molecules. So a different type of a force causes different types of cells to
could be.
Yeah, so and this was new to me.
Yeah.
And so basically the type of the mechanic force is directing, and I don't know if it's random or if it's could be random, but it could also be that now we have enough of the power, enough of similar cells, so something change in the constitution, so that automatically it ends up in different direction, the force becomes isotropic.
What usually happens in physics is what they call symmetry breaking. You have something that's isotropic, that means all directions are equally good.
Yeah.
And then to some random event, one direction suddenly gets a little bit more pronounced than the other, and then to a positive feedback, that dimension, that direction becomes dominant. And it may well be what happened during cell division, because what happened during cell division, I know, it's by something called microtubules, which are kind of small tubes that grow, and those tubes actually pull apart the chromosomes, so that one half of the chromosomes go in one cell and one half go in the other cell. So it must be in a particular direction. If they push in all directions, the chromosomes will be all mixed up and you can't separate them.
Yeah, but I think, if I understood correctly, this is from the field of biology that they were lending this phenomena, or I think one of the researchers was a biologist. What they were saying was that before you start the process, you have a force. So the force is triggering something to happen, and if the force in the cell is anisotropic, then you end up having this. It was about exactly how you said that. It's either the cell is pushed equally to all directions, or it's pushed you know, unequally, and then the outcome is different. So this is what they were saying.
Mm-hmm.
Yeah, but and I think I read like I wasn't searching with that word, but I found with using this topic number 3, the deformation, I found 2 or 3 quite recent articles. So it wasn't just one. So yeah, but that was interesting. Yeah, but so that has to do with the alignment. Then yes, yeah, and it's definitely on the list of, you know, these other theory, method, material combinations that I need to consider. I will hopefully end up, you know, having like 5, and then I'll do some reading and see which one is most suitable with the data that I have, so the online data.
There's another method.
Because it has limitations.
There's another method that I like, but I don't know whether it's used much. It's spelling activation. If you can make some kind of a network between your articles by links such as citations, co-authorship, use co-occurrence of the same keywords, and you have a strength on the link, so that two articles are very similar, like they have the same authors, they refer to the same things, they use the same keywords, or they have just one keyword in common, or the one author has collaborated with the author of a third article and then collaborated with the author of this article. It can be a quite weak link. Suppose you have such a network with links of different strengths, and then you select a couple of articles that you consider to be very representative. You activate those articles and you let the activation spread. You make sure that there's a threshold so that it doesn't spread over the whole network. And then those articles that get activated are likely to be articles that are closely related to your topic. Especially if, let's say you have 3 articles that you consider very relevant, and those 3 articles are all 3 related to a 4th article, maybe not so strongly, but they are all 3 related to it, then probably the 4th article also belongs to the cluster, and it also is about a topic. But for that you need to build a network of
authors.
Associations, which can be authors, which can be citations, which can be keywords, which can be similarities. Ideally some combination of all these dimensions. The more dimensions you have, the more likely that the articles you have are really associated because they are really working on similar topics. Yeah,
the thing with author connections has been that I know that in some fields people tend to work alone, so they don't work in groups. Sociologists, yes, philosophers. In different countries it might be different. That, for instance, in the UK you have the professors writing all the articles, even though the PhD students and lecturers help them. But combined with the keywords and references, I think I've been a bit hesitant with the network analysis because it's done so much. But I think I need to try it eventually.
Yeah, but usually what they look for
and then
networks
like
are different kind of things.
Yes.
This spelling activation, I think, is a very powerful method, and it has not been used that much.
Yeah. Yeah, but I know what you're. I understand what you're saying, and I think I've been overlooking that for a long time. But it's definitely also something that I will have to try out at some point. I tend to think that sociology is so much about categories, and economics is very much about like there's like a list of things that people take into account when they are making decisions. There are some more advanced methodologies like what was the term? I wrote it somewhere. It's there on my list that I'm not showing you. But it's multi-criteria decision making. So there are like more advanced more advanced ways of doing this, but I think I kind of got fed up at some point because you have to think about all these things, and then in the end the personal preference list is somehow random. But of course in brains there's
multi-criteria decision analysis and identity impact it's useful because these criteria are all quite subjective, and what are the relative weights to them, and what if the one contradicts the other.
But
these models may look nice mathematically, but in practice I don't think they're
I don't think either. I see that they're coming from neuroscience, so they are probably useful and relevant, but I think that it I don't know, it adds to the complexity. I was actually surprised to notice that one model that I used in 2005 in my master's thesis, and that was already old by then, it's still used in like technical acceptance model, and then you have additions like there's 30 different things that you can take into account when you're accepting a model, but it's still never, never know for sure if people will accept your product or not. Anyway, personal history. Activation, I haven't considered this, but I probably will have to, like a list of things to consider, and somehow how they might affect, how different, they might put different weights into what kind of articles are considered important.
I'm also thinking about the next step. And then now maybe you are looking for some topics among these keywords, among these disciplines, and I think the next step may be to define a problem. Not just a topic just a research field, but the problem maybe you could make the focus on. So I'm thinking if there is a philosophy of defining this kind of problems to help you.
That's one of the big lacking things. That's the theory of problem formulation. I once heard a paper a very long time ago. It was called Formulating the Problem of Problem Formulation. But I haven't seen any follow up on these kind of things. It's one of the very important things, and that especially PhD students often have troubles with formulating their problem.
And I
think
a
good problem formulation is already the half of solving it.
I agree with you. I know that the problem that I have is very vague because it's so very general. It's very general, and this is also, like I said, I have this kind of a process and a path to take to try to find it from here. Oh, sorry, you're not seeing it. I'm showing you things only on my screen. But trying to find from here exactly what you said. What is the kind of a problem that I'm solving? Is there a problem with people? Do the people have a problem and then I want to offer them a product? No, this is not the problem. So that kind of drops many kinds of things out of the list. Am I interested in studying interventions and A affecting B? No. The nature of things when you're giving a big set of data and said find something interesting about this is exploratory, but I can't write a PhD thesis that is exploratory. I should have a problem. So I'm trying to find a problem that is very specific and well defined, and that interests me while using the material that I was given. But it's a very good comment. It's a I think this last, yeah, it was actually, no, it's actually this one. So looking at this, these blue words is actually kind of key to me. Is it the that I started to think what exactly is the problem and what is the focus? Because like I said in the first article that I showed you, I was like, yeah, they are studying the audience, and the audience is evolving, but actually it was the brand that was evolving. So yeah, I definitely need to focus on this too, or yeah, more, yeah. What is your topic?
My turn.
Yeah. Are you going to give a presentation?
No, maybe several months.
Okay.
Several months, yeah.
Yeah.
And it's about the design methodology of complex engineering systems.
Okay.
Yeah. In one word,
is it about business or architecture, like technical architecture, or
architecture
yeah.
of physical
yeah.
material.
Okay.
From the perspective of engineers.
Yeah. Okay. Okay. I sorry about that. Yeah, I think we should stop quit instead of me asking questions from him.
Yeah.
But thank you for this. It's
Thank
been
you.
a pleasure.